good afternoon, everyone, and welcome to this webinar hosted by the Process Control Methods SMIG team. My name is Niklas Gödeby. I am a senior manufacturing engineer working at GKN Aerospace. So this webinar, Process Control for Manual Data Collection, we hope that you will find it, this webinar, and that you will find the material that we will provide afterwards helpful on your way to deploy and or develop your company's ability to work with SPC. Next, please. So the agenda for today, we will have a quick overview of the AESQ community and the SMIG team where we are responsible. And then we will have the presentation, and afterwards we will open up for questions or comments from you before we close this. And we hope that we will be able to bring this to an end within the hour. So next, please. Yes, we are recording this webinar, so it will be available on AESQ website afterwards. This presentation that we're showing will also be available on the same website. And asking questions, do that during the entire webinar. Write them in the chat, and then we will summarize and go through that in the end. And please remain on mute during the presentation to prevent background noise. Thank you. So here is the team. Participants from our SMIG team that has helped out with creating this webinar. As you can see, multiple years, 20 to 25 years per person in aerospace community, working with process control methods, process development. And we are really eager to help you with all kinds of questions or comments that you have when it comes to deploying SPC. Next, please. So the process control methods, RM 13006, that's a reference manual that is supporting the requirements from AS 13100 with regards to deploying and using process control methods. And so process control methods, they can be such as mistake-proof, SPC, or other kinds of ways of making sure that the process is working. The process control methods SMIG team is the team that is responsible for setting up this and for the what's in the RM 13006. So there are multiple members from different companies that helps out with this. And besides from looking through the RM and developing that, we also have a community of practice on LinkedIn. And we also have an area on the AESQ website where you can find supplementary documents, or you can ask questions or whatever, where we can provide help or guidance. And you can see the two QR codes in the presentation, so please use them to find the correct locations on the web. Next, please. So here we see the entire SMIG team. and you can see the different companies that we represent. So there are most of the large companies in the aerospace engine industry, together with some of the other members as well. So now it's time for you to help us a bit. As you can see, we have a QR code to a Slido, and we would like you to enter that. The passcode is SPC, and give us your information on how SPC is performed at your company today. And we would like to, it's not going to influence this webinar, but it's an interesting thing to know and to understand how the opportunities are. So thank you. Now the numbers has stabilized a bit, so I think that we can move on. Thank you for that information. So why then manual SPC? Why are we supporting and highlighting this in a webinar? Before we start, so I have a bit of a confession to make. I have never done manual SPC myself. My company was quite early digitalized. Big benefits with that, but also creating a bit of lack of understanding of what data you see and how to work with that. So this webinar and making this webinar has been a truly interesting for me myself, because there are questions that I have asked myself. How does it work? How do you do the manual version? So I have asked a lot of questions regarding this, and the other team members has really politely helped and answered. And I think that what you will see when we go through the webinar, that it is a very hands-on, step-by-step instruction for how to utilize and how to do this in a good way. We are in a really high digital era. People talk AI solutions, and companies provide different kinds of solutions that is out there to buy to get SPC within the production premises. And at the same time, it can be hard to understand what are the needs, what should be there, and that perhaps also that you want to make sure that you're betting on the right horse, that you're getting something that will make a benefit to you. So what we would like to do with this, and that is to highlight the use of manual SPC, that it's not something that is the reserve version, that you can do it, that it brings strengths to your company performing it as of today. So there are a couple of things that we want to highlight. First of all, you can start immediately. Hopefully with this webinar as a baseline, you should be able to go down to a machine or a work center today or tomorrow and start capturing data and doing this. We can sense sometimes that people are organizations are on hold for SPC. They are waiting for these digital solutions to appear. But you can start immediately. And also, if you're going to look for a digital solutions further down the road, by starting now, doing it the manual way, you will learn. You will understand what will be the requirements for your company. What kind of things do you want to see in your setup? So by starting using the manual SPC, it will also be easier to understand the requirements needed for digital solutions. It will also give you the opportunity to add process controls to your process inputs, not only to measure what comes out from a final inspection, but also give the operators in different machines the opportunity to measure temperature, concentrations, things, whatever it could be that is affecting the process, and to follow that directly when they are performing. It involves everyone, because operators themselves will capture the data. They will calculate data themselves, and they will make them more aware of process drifts or anomalies. And finally, it's easy to add documentation to that process behavior. So an operator running a process can hear something, see something that you might not see in the data, but can be interesting when you're trying to understand why things are different, or why you have process variations. Next one. So before giving the word to Tony, that will present the fundamentals of SPC, I would just like to highlight that there are a number of webinars and presentations online on our website that is related to SPC, Perform SPC, and they are good to go back to and read through and bring with you to your future work. And now I hand over to Tony. Thank you.
Okay, good afternoon, good evening, good morning, wherever you are. My name is Tony Sweeting. As it says there, over 25 years in sort of aerospace, but also been around other particular manufacturing areas. And that's about as much time I've got to explain myself. So let's get straight into it. So these are just going to be some of the fundamentals of what we do. So these are sort of, you could call them tips, but really they are the fundamentals. And that's why there was a little brick wall being shown on the first slide, which is if you don't do these things very well, you're going to get a problem later on in trying to understand your actual process and its control. So to start with, if you're doing any kind of digital or manual, and again, we'll get into why manual can have its bigger benefits, similar to what Nicholas said. First thing really is, if you're going to measure anything, you should check that it's capable, whether it be an input, an output from the machine, dimensional or visible, anything that you're going to measure, make sure you are really sure that that point you plot on a graph, manually or digitally, is kind of where it should be. You can't second guess, otherwise everything falls to pieces. So, and the measurement system analysis, I'm sure our MSA guys on RM 13003 will have many webinars to take you through that side of it as well. And there's good information, but it's a cornerstone of making sure that you're ready to do process control. First check. When you're plotting any process data as well, make sure it follows the order of manufacturing. It seems incredibly obvious, but you'd be surprised the amount of time I've seen it not in order. Not because people don't know that it doesn't matter, just because we actually may measure or batch out of order. Sometimes the first thing you may eat may not be the first thing you measure. So ensure that you try and understand the process as it evolves. So it's how it was made. How it was measured is of no consequence other than making sure that it was measured accurately, repeatable, and the rest of the MSA. So really important, make sure it's when you made it, not when you measured it. If you're going to measure anything and you're going to implement it on a shop floor, again, to the process owners who would be the operators themselves, make sure you've got a plan. How do you want these people to react? If it is shrug of shoulders, just tell me when it happens, then you'll be constantly bombarded. But at the same time, you don't want them to keep adjusting the process based on overreaction. Somewhere in between overreaction and underreaction is the right place. It's probably going to be iterative and you might not get the perfect reaction plan, but start with something. Otherwise, the charts that you put out there will be ignored because they don't know what to do with them. So there has to be an action plan. Hopefully part of the control plan. And with all of that, people need training and coaching on this. And anyone that this touches, and anyone that might touch these control charts, which generally should be anyone that has anything to do with this process. And that could be people that plan it, the operators, the engineers that have designed it, anyone in the logistics side of it as well, maybe have to be involved if there's damage related issues. Anyone that touches a process physically or metaphorically speaking needs to understand the purpose of process control and some of these fundamental checks. They don't need to be experts, but they need to know enough to understand why is it important to do this. And a lot of that is the buy-in. We'll get into that a little bit later on. If you have any problems in terms of planning the training, RM 13006 talks around the fundamentals of how you have a good training plan and sort of a tick box in terms of these things should be in it. I always say it's a really good reference manual for, actually, I can almost make slides from this manual. But please reach out if you're struggling or you don't know quite the level to train out. That's why we're here. Next slide, please. Okay, so quick one on pre-control and control charts. Sometimes there's some confusion. Sometimes where I work in particular within Rolls-Royce, pre-control charts can be confused with control charts. They have the same words in them. They just forget to say the pre bit. This is for the people that may not fully understand that. And there was certain people I saw that said, we don't really use SPC. Don't confuse pre-control charts with control charts for variable data. They are significantly different. As it says here, pre-control charts are process limits that you've defined based on, more than likely, a definition or a spec from the drawing itself. If it was dimensional, it would be the drawing, and we would say approximately 50% in. Again, Jocelyn will go into that a bit further detail in a moment, though. So here we've got the points plotted, and we've got warning limits is the best way to look at it. They are not control limits, even though they may help you kind of control the process. But they're warning limits to tell you you're getting near to being non-conforming. Control limits are something different entirely. They tell you something else. They tell you about the process itself. Going back to the manufacturing side, it tells you this is what we manufactured previously. I'm making limits based on where I think your process sits and the width of that process as well. So the spread and where it sits, that's what it's telling you. So once the pre-control is saying this is where I would like it, the actual control limits are, well, this is where it is. So you can see they're significantly different things. One's a wish, the other one's a this is it. Hopefully that makes sense. There'll be a bit more detail in a moment. But keep in mind that that's okay to do pre-control before control because you may not have that detail. Next slide. Okay, another thing, it seems to be the default that we do a lot on individual moving range charts, as they're called, for those that don't know. In other words, we plot every individual point. Here we're talking about subgrouping, and it's normally called rational subgrouping. And it's rational for a reason. Does it make sense rationally to subgroup this data? And in this particular case, we've got two instances on the bottom left. We've got subgroups that have been rationally subgrouped based on, I've got 5 measurements, let's say, of a diameter, and I'm just interested in the average diameter. It makes sense to capture that data because I would like to understand if there's a big spread, but in the end, I'm just interested in, on average, is that 50 millimeters, let's say, in diameter. But I'm still interested in case of deformation there. Again, the default is sometimes I don't even see the subgroup, I just get the average. If you're getting all the points, why not use them? Why not see them? But we can do subgrouping of data. The other more obvious one is if I'm making 5 parts on the similar machine on for a similar feature at exactly the same time, I'm probably going to subgroup those parts together because it makes sense. It's, again, rational that I should do that because splitting it out into individuals, I would probably see clustering. Those 5 parts would be up here, the next 5 here, the next 5 here. And when you come to control charting, it would give you limits that wouldn't make sense. On the right is a Minitab output. And really at the top is showing between subgroups. So what it's really done is convert the charts on the left into a single point and then saying between subgroups, this is what it looks like. And at the bottom is showing you something you wouldn't be able to see unless you did a chart on the left, for instance, which is within that subgroup, what's that spread? And when the spread is very large, you need to then worry about how that average was derived. That's generally it. I know it's quite quick for those who are not familiar with subgrouping. The main thing to remember is think about subgrouping. Don't default to just doing individuals because it's easy to do. If you're getting unusually tight to control limits, you're probably using an individual when you should be subgrouping maybe. Training, understanding the charts is part of it. Please get in touch if you struggle. Next slide, please. Okay. People have probably seen some of this before. It is the general, well, funnily enough, it is the Western electric rules, but it's generally the way we would try and classify something that we didn't expect to happen. The control limits we draw are there to tell us, I think the process should be somewhere within these control limits. My estimate from 25, 30 points is, I think they should fit within these control limits. These tests are here to tell us something's changed. This is not what I expected to happen. And I'm telling you about it. Here's a test. The easy ones are obviously, if it falls out of the control limit, which is test number 1, this is not what I expected. This is new. I won't go through all the tests, but test 4, for instance, another simple one, we seem to have a trend and it could be going up or down. Something's unusual. This is not what I expected. I expected it to bounce around that center line, and now it isn't. Test number 5, my averages or my mean has suddenly dropped in this particular case. It's not where I expected. It's In this particular case, 1 standard deviation below where I expected. My average is shifted. So I'm still within my limits, but my average seems to have shifted. I'm just telling you. Thing to note, the special and common cause often used in these particular cases. Easy thing to remember is this. Common cause needs to be understood and is a lot harder to define sometimes. Generally, it's something where we need to improve the capability. Special cause, we can investigate it. That in a way, they're the little gold nuggets or pearls of wisdom that we can learn from, because there's something different about them. There's something special that we can learn from, because we really are saying this is very unusual. So it's a good point to grab that data point, although clusters of data points, and go do an investigation. And special cause does not mean it's bad. It just means it's different. You never know, we could be making more suddenly that are more conforming than we ever did before. We should still find out why that is. Okay, that's, I'm not going through all of the tests, but they're a good guidance based on using control limits. You can only do these tests if you put control limits around. You don't do this around the pre-control. There are different tests for that. Next slide, please. I am seeing some questions. I don't know whether I should leave this to the end or not, given that I might run out of time. Well, I'd probably leave that to the end and see if we can answer it. But thank you for the question. Last bit from me really is, this is a very simple, well, this is almost exactly the same slide that was presented at an earlier webinar end of last year. So if you're interested in terms of how do you get over the resistance, please look at that one. But really, I'll go through this fairly quickly because, like I said, the detail was on the previous webinar. This reiterates what you need to do this. And sometimes manual charting does this really well. If you're trying to teach someone the importance on get an understanding, I've learned, get a piece of paper and a pencil and draw control limits, and it starts to make sense. Pressing a button and it making it, Minitab's great, and his jump and other and spreadsheets are brilliant, but I would suggest going and doing it manually first, so it makes sense. Promoting it as well, the easiest way to promote it is show the quick wins that you may get, and that's probably building that critical mass as well while we're there. And selling the benefits, maybe, let me do it manually first. I can show you it's working, and then let's spend a lot of money getting that digital system in place. In other words, don't waste your money if it's not worth doing. Let's have a go manually. Teaching and coaching, one of the same thing. If I've got a manual chart there, it's a lot easier to speak around, I would say, and to get that engagement. It does say engage the digital teams. You are going to have to, once you've said, this is what I've tried manually, is there a way I could get this digitally? And as Nicholas mentioned, there's a lot to do with tacit information that an operator knows, but you won't get it from that dot on a plotted on a graph. They may, how do I add in that person made an unusual noise, or I didn't notice this wasn't lubricating, or we've got a leak. That doesn't get shown on a chart. Planning, any implementation would be, well, maybe I'll do it manually, then I'll start to stage it into the digital realm. Piloting, so it goes again, piloting might be fully manual. I'll pilot it, see if I need it. It may be that the process is brilliant, actually. I probably should apply it to a more problematic bit of the process where it has lots of variables, but here I can just do it manually, maybe. Not everything has to be automated, believe it or not. And if you are doing anything manually and testing it, you are involved in that workforce, hopefully, while you do it. Okay, I just very quickly went over that, but that helps with the resistance as well. So sometimes manually doing this gets the buy-in early on, and then you can show all the very sexy control charts on a particular computer screen as well. Okay, let me introduce you to Jocelyn, who will now take you through the step-by-step, a bit more detail in some of the pre-control charts and control charts as well.
Yeah, many thanks, Tony, for your time to remind us all those SPC fundamentals. You will see that we will continue to insist of them today. So good morning, good afternoon, good night, wherever you are right now. My name is Jos Gauthier. I'm working in ITP Aero for more than 12 years. And I will please today be kind with me because it's my first webinar with the AESQ. I'm not an English speaker, so I will try to do my best. Okay, so you can go next, please. So the first step is always to plan. As Benjamin Franklin was always saying, if you fail to plan, you plan to fail directly. So I will remind a few things that everybody has already talked before. The first key is to ensure the management support in order to be able to launch this kind of program. So you need to talk with them. You need to explain them like what is the target to implement this kind of SPC. Explain them that the aim is to save money, to adjust to the process only what it needs to be touched. Okay, so which is quite important. Second point is to select correctly the correct scope. So here, my personal tips is try to select a part, an operation, a characteristics that you are struggling with. Imagine, for example, a part that you have a lot of rework, a part that has a lot of concession due to different points. Use this one and make the process more reliable and with less variation, which is the aim of the SPC, right? So really important to select the adequate scope. Do not select too much characteristics at the beginning because it's quite difficult to control everyone at the same moment. Next point, really important. We may perform a future webinar in order to explain and go in detail for that, but the measurement system is a key point within the SPC. If you do not have it validated, fit for purpose, and adequate, you can introduce a lot of error within the own SPC, and you may take wrong decision. We are not talking only about if the part is okay or not okay. We are going further. The measurement system should be able to detect change in the process. So it's really important to validate it. So please have a look to the reference manual 13003. Explain in detail for that. Also, you need to have a look on the operation. Do we have a reasonable standard work at this operation? Are people, are operators working in the same way or similar way at least in order to ensure that we may be able to understand where are the problems, right? And as we already talked before, training is really important at all levels of the organization. So the first one will be with the management in order to explain them why we will save money introducing SPC. Second step will be also with staff like manufacturing engineer, quality, people that will help and that will participate on the analysis and the problem solving on the process, right? And after that, really important is to explain key people in this process who are operators. As you know, on manual SPC, the operator will be the one who take the measure, who will report the value on the chart and raise the hand when something is not going as it should. So we need to train them. We will see afterward what we need to do for that. Next, please. So great. The first question on the step 2 is, do we have historical data? So if we have already historical data on what we plan to perform SPC, we can skip this step without any problem, and we go directly to step 3. In case we do not have historical data, this is a perfect moment to start with a pre-control chart. As Tony was explaining before, the difference is the pre. Pre mean that this is only a temporary situation. This is the control chart that we use before using the real one. So big difference is this control chart, we do not have historical data. We are not able to calculate a control limit of our process. So let's go with it. And we use it against the drawing tolerances, okay? So this is also a way, so you take the chart, you bring the chart to the shop floor, you explain to the operator, please gather data point. The aim is to gather around between 25 and 30 points, that could be subgroup or individual value, in order to have enough historical value. And also explain to the operator, please write on the sheet if there is anything strange that is occurring during the process, like noise, like unspecific alarm that is popping out or introducing a new batch, anything. All those information that you see on the bottom right is really useful after that in order to be able to analyze what has occurred on the chart. And this is also a preparation about when we will put the real control chart on the shop floor, right? So once we have developed that, we put it on the shop floor and we gather around 25 and 30 data points. Now we can go to the step 3. So next, please. So great. So we've got 25, 30 data. With those data, we will be able to calculate and to prepare the sheet that we will put again on the machine, on the workstation. So all those templates are already available within the AESQ website under the material tab. You will see that everyone have already all instruction about how to calculate control limit, how to plot it after that. In this example, we are using, let's say, the common one that we're using a lot in the aerospace company, which is the individual and moving range chart. So using those 30 data, 25, 30 data that we obtained before, let's plot the new one. So we prepare, the sheet is, let's say, is with no data at the moment, and we plot correctly the average at the middle, and after that we plot also the control limit on the individual value. After that we do the moving range, so down. So on the moving range, things that you need to take in account is that always the lower control limit will be always 0. This is natural limit. And the upper limit, we will calculate it using few specific factors that you can find on the sheet without any problem. So great. So now we've got our sheet ready to be on the shop floor. So we can go to the next step. So great. We are in the best situation. So let's take the sheet. We go to the shop floor. And when we explain, we gather all the operators that are working. We need to think about all shifts that are working on this station, and we need to explain them. We need to explain them what we are expecting from them. So really important, always explain and why we are doing that. We are doing that to reduce the variation. We are doing that to reduce the number of concession of this area, to reduce the rework, for example. We need to explain to all the operators how to fulfill the chart, which is quite easy. So we explain them, you take the value, you report it here, you draw the first point, and you check that it is within the rules that we need to define. Really important, as Tony was saying before, it exists a lot of different rules from the Western Electric rules. My recommendation is do not use too much of those rules. Select 1, 2, or 3 maximum according to the process you are doing. So, for example, the out of control limit, this is one of the main and the common one for everybody. And explain to the operator what he needs to do if he finds some out of control point. This is really, really important. So at the beginning, imagine if you do not have a lot of knowledge about this process, you maybe do not know yet what to do on this process. Do we need to adjust? Do we need to introduce a corrector? Do we need to do something else? Maybe at the beginning you do not know that. So you will need also to be ready to react quickly. So that means at the beginning, if you do not have any information, you will ask the operator to raise the hand, maybe call the supervisor, and they call manufacturing, engineering, and quality in order to be able to analyze. So you will need to be ready and react quickly. There is a thing that we, in order to help in the future, once we gather more knowledge about this process, about this part, about how it is reacting, we will develop new reaction plan. We will develop more action against any of the out of control point. So let's go to the next slide, and I will try to explain you what is the best way to do that. So the best way is to use directly the control plan. Within the control plan, we've got a specific area in order to write the reaction plan. So as you can see here, for example, we are explaining, we've got an airfoils, right, that we are measuring in cmm. We've got an individual and moving range chart. And we have already explained to the operator what to do in case of finding any of out of tolerance, out of control point, okay, not out of tolerance. So always think a few tips in order to remind. Always think about what to look for and what to check. Sometimes we need to check that the part is clean and everything is clean. Think also and define what could be a recovery action. If we are talking about, for example, about a chemical bath, you can say that had 5 liters of this product, for example. Think also about when to stop the process, which is also quite important to deploy. So at the beginning, we may do not have all those information, but once we gather more information and we know better the behavior of the process, we will be able to define it much more. Okay, so next slide, please. So here, we've got it on the shop floor. The operator is happy, the operator is measuring, is reporting on the chart, and he will have to take few decisions. So if the process is still okay and there is no out of control point, so he can continue the process. If there is out of control point, he will have two choices. Do we know what to do? Is it already explained within the control plan, the reaction plan? Yes, so I will apply this information. If not, I will call the supervisor, and the supervisor will call manufacturing, engineering, quality in order to analyze what happened at this moment. Once we gather more and more knowledge, we will be able to give more autonomy to the shop floor and be able to explain that in this case, do this thing. In the other case, do the other thing. So it will be really good and the process will flow naturally, and we will modify the process only when it needs to be modified, okay? And we will not add more variation to the process, okay? So great, so we are doing that. The operator is taking the point, reporting on the chart, raising the hand when there is any problem, or following the reaction plan. Once we finish the chart, so around 25 and 30 data point again, we can go to the step 6. So next slide, please. Here, it's again, we continue and continue and continue. Let's take the chart. We use all the data that we've got on the chart, and we calculate the new control limit, the new average, and we report it on a new blank sheet, right? In order to be able to give again to the operator, or the operator itself in some mature company, can draw it and put it on the machine and continue to take the data and value. So from that, we will have introduced a manual SPC, which is quite important. Just to remind few things, SPC is not new. SPC is around 100 years. It was started in the 30th centuries in the laboratory bells, and everybody was doing it manually. There was no computer at this moment. And as you can see also, one of the good benefits is also that we involve the operator, and the operator is the best person able to detect what could happen on the process. That means it's got a lot of information about noise, about anything strange that could occur, that automatic system does not necessarily gather. So the operator is really important there. That's why I really like the manual SPC. Next one, please, and we will finish. So great. Now we've got our sheet. What we can do? We can calculate CP/CPK. There are also the instruction on the sheet, which is quite easy to calculate, and we can report it. Something that we can also take in account for the next SPC sheet is if we have a special cause event, let's say an out of control point, and we know what has been the cause, and we have corrected it. We have put a corrective action for that. In this case, and only in this case, we can remove this point from the calculation for the new chart, okay? Also, we will gather more information and improve the control plan and reaction plan. And the last, and for me, the most important tips is, and this is also something, whatever if we are doing manual or automatic SPC, we need to ensure a smooth transition. So that's why I really recommend to implement a go look and see, a regular one, also include the management in order to ensure that we go down, we check on the shop floor, and we discuss with the operator if there is any doubt, if we can help in something. This is really important in order to ensure a smooth transition. Okay? And with that, I finished, and I will let Steve continue and present you the different control chart that exist.
Awesome. Great job, Jocelyn. Thank you very much. Hello, everyone. My name is Steve Hampton. I work at Precision Cast Parts. Been the process control manager for the last 10 years. And I'm going to talk about some other charts. And we've been mainly talking about the IMR charts, the individual moving range, but there's a lot of other good ones to use. So next slide. This is out of the RM, but Tony did a great job to make it all in one slide for us and also color it nicely. So thanks for that. So this gives us an idea. We've been talking about the individual observation, so that IMR kind of like right above the line there in the middle. But we got a whole bunch of other things. The subgrouping is kind of that big chunk above, and that's where you are having rational subgroups. And so when you're manually charting that, it can be done. It just takes a little bit more calculations than because you're plotting an average versus a individual point. And if you get into the S, then you have to calculate the standard deviation as well. So hopefully you're just in the X bar R, just for a little bit less computation for your operators. But it's not the end of the world if you are doing the X bar S. And then the IMR, the IMRS, the three-way control chart gets, yeah, it's basically the same difficulty as your X bar R or X bar S. And so it's just there's an additional chart panel that you'll need to train your team to. And then down below, if you're going to be actually looking at defects or defectives, then you have your C chart and your U chart and your MP and P charts. So, and I did put a little asterisk here. There is the target to nominal charts, where you are actually plotting the difference from your individual value to the target. And so you can use that on your IMR, but also in your X bar R and X bar S. And to give you a little bit more information on when to use this, if you can go to the next slide. So this is, you know, a little cheat sheet as well. So you have your flow chart, and this gives you a little cheat sheet with some additional information. And then ultimately, if you want to really dig into the details, section 5 and section 9 of the RM will have even case studies and walk you through this in more detail. But your target to nominal, this is when you have like part families. And so instead of doing a control chart for each part family, you can actually put them all into one chart because you're going to be looking at the difference of a value versus the nominal for that family. And so then that way it normalizes across the families, and so you can keep it all in one chart. So that's a really handy way to keep your control chart density down, so you don't have to have an excessive number down the floor. So that makes it easier for operators and engineers. So yeah, so really you're looking at families. So in this case, for example, it's where you have some bushings and you have different diameters across different part families. The charts for averages and ranges. So this is where you're going to actually be using subgroups. So in this case, you could have a batch. You're going to run, let's just say it makes sense to have just for a day. So I'm going to run it for a day, a machine, and then we shut down for the day, and then the comes in the next day and starts the machine back up. So the day is the subgroup. We're going to take just random parts throughout the day, and that's going to be the subgroup for the day. And so we'll chart that. The IMR RS, the three-way, this would be where the in-between variation of the subgroup isn't a good representation of the total variation that you'd have in your process. And so in this case, let's say instead of the subgroup being something that you shoot the die. So if you're shooting it, a die, one part comes out, and so you're taking a random sample of that. You might have something where a die shoots like 5 parts at once. And so if you use that as your subgroup, because you're shooting all 5 parts at the same time, the variation within that die could be incredibly small compared to the variation between shooting it. And so your control limits could be artificially tight, and everything's going to show up as out of control. So in that case, your IMR, your RS, your three-way chart, will look at the variation between your subgroups and let you know if something shifts there. But you still have looking at your R, your S for within the subgroup, and so you can see something that shifts there. So that's a really powerful control chart. And so both the target to nominal, the IMR, RS, and the IMR was done on a previous webinar. So if you go back to the beginning when we had those links, you can go and review that whole webinar. That goes into a lot more detail. It's a great webinar. So, and then you just have our attributes. So we have our P charts and our NP charts for when you're using proportions. So that's the binomial distribution, and the difference being there, are you going to use subgroups or not subgroups? And then you have your control charts for number of defects. So your C chart or U chart, C chart for individual, U chart for when you're using subgroups. So yeah, so those are the most common ones that we feel like most people are going to use for the manual plotting. And if you want to you have unusual situations, you can manually plot them, but they can get a little bit more difficult. And so you can look at that lesser known control charts, get into like the EWMA and the Q-sum and stuff like that. And there's a webinar on that as well. So all kinds of good stuff out there. And with that, I think we can go to the next slide. So here's our group of SMIGGers that put together this presentation that are here to help answer any of your questions. So I think at this point, we will open it up. So thank you very much, everyone.
Well, I can say something. Great webinar from all of you that has helped with this. So we have a couple of questions. First one is, what are the control methods allowed in process control plan? other than the 9 process control methods defined in RM 13006 standard. And I don't know if the team has any other take on that. My take is that the RM is a reference manual, so it gives you guidance. We don't disallow anything. If you come up with a way to control your process that you feel is confident, then that's what you should do.
I would agree. It is it's not necessarily they're kind of in order of the best to the worst, but they're not definitive. So if you've got better ways of controlling and there are variations on that, again, it is a reference. So it's not prescriptive in that way, I would say.
Yeah, I fully agree with you. I think the aim also is to do not stay on simple inspection, right? Which is not a control method, the simple inspection. So first, have a look about all the methods defined, the 9 within the pyramid. And after that, maybe you have specific things that is also working for controlling your process, right?
Yeah, thank you. So then the next question, quite a long one.
Interesting one.
We use defect prevention tools, PFMEA, CP, SPC charts for process inputs and outputs to achieve PPK larger than 2. However, sometimes we are unable to identify special cause from the machining process. Is there a technology which control, minimize, identify machine variation due to material homogeneity or others, cutting force, temperature variation, etc. during the machining process? Please advise.
Not an easy one, eh? It's a complex one, I would say. There is no a simple answer for this kind of complex question. According to me, according to the knowledge we have within our company, we know that it's not easy to identify the machine variation, right? So there are different tools, but there are more advanced tools in order to ensure and to see if one of those factors is really the one affecting to the variation. So you can perform kind of DOE and this kind of thing, but it's quite difficult. What I would recommend is try to be the most on real time possible. So that means do not wait to have the complete sheet, the complete 25 part or 30 part and analyze. But at the moment that there is something out of control, go to the shop floor, analyze the part, confirm your theory. So you say, no, it was the material homogeneity. Okay, let's take the part and let's see if you can make an analysis in order to confirm that. But the most real time possible.
Yeah, I think the other thing to remember is you will get false positives with control charts. They are built around, the 99.73% being within there, and you're going to have this small fraction that will just be not like common cause, and that there shouldn't be anything you find. So the higher the volume of parts go through, that might seem that's like, oh, we're getting a lot, but if you look at it versus that assumed false positive rate you should get, if it's within line of that, then it's probably just the false positive.
The only thing I would add, and I don't know how popular this is going to be, but I would say just because you've got a good PPK doesn't necessarily mean that, and I'm guessing this is on the inputs and outputs, doesn't necessarily tell you the sensitivity of those inputs. It may be, if you can't see the correlation, then maybe the measurement system isn't good enough and is sensitive enough to tell you that. And no control chart will fix that until you find a way of making those more sensitive. It feasibly, if you can't see it, then either it really isn't there, or you need to find a way of capturing something else or raising the resolution of whatever you're measuring, because you're obviously getting some non-conformance. So you must be can't be magic. Something has to have made it. That's all I can say.
So the next one, can proper sampling frequency be determined based on CPK?
For that, you need to follow the S13100 and refer to the reference manual 13002, where all the possibility regarding alternate inspection plan are explained without any problem. Okay.
Then we have interested to get feedback on live feedback system on machine probing and the monitoring of process control. Are there any lessons from the group on this? Well, my experience is that once you get it up and running, machine stability will reduce variation compared to have multiple operators running a process. But I don't know if we have any presentations or anything else regarding this.
I can try to answer this one. We can all, I think. And for me, the most important benefit of the SPC is to do not touch the process when you don't have to touch it. So I mean, a lot of time, natural reaction is, hey, I see variation, I will change something. And this is sometimes the worst things that we can do because we increase the variation. So instead of doing that, use the control chart in order to ensure that you touch the process only when you should. So for me, this is the best saving, and you will see that naturally your process will reduce its variation.
For me, I always try and sell it and say, would you like to be able to predict your planning for your business? And you'll only get that if it's a predictable process. And real process control is where you could predict something is about to happen and you do something about it before it does. That's controlling a process, not reacting to it. And that's proper process control. So that's the way I sell it. You could plan your business better.
Yeah, perfect. So we got another question here, and this webinar will be accessible afterwards. It's recorded, so you can see the webinar and you can download the presentation as well afterwards. In a couple of days, I think it will be available. Is there anything else? Perfect. Well, so then we are done. A bit over an hour. Thank you for participating, and once again, thank you for the team that helped out to create the webinar. So the PowerPoint that we do will be available on AESQ website in a few days, and you will get an email sent to you with a link. So thank you very much for today, and have a pleasant day or morning or evening or whatever. Yeah. Goodbye.